Good morning, students. Today we can discuss about the design of synchronous upcounter using JK Flipflop in the subject digital principles and system design. So I am Dr. S.D. Vivendros, Assistant Professor at Department of PCT, R&D Engineering College. So we can the steps. What are the steps to design the synchronous sequential circuit? And we can have all the what are the what are the various steps as well as we are going to discuss about the implementation part in this particular flip-flop. Okay. So what are the things we are going to discuss is design a synchronous 3-bit synchronous up counter using JK flip-flop, right? So in this the design, how we are going to explain is first we have some various steps, right? So what are the steps to be followed? First we are going to discuss. Then we can discuss about the discuss about the problem with the JK flip-flop. Okay. So in general, we have the steps to be first it is the number of flip-flops. So number of flip-flops as well as the type of flip-flop. What is the number of flip-flops? Is number of flip-flops is equal to the number of bits. So in this example, it is 3 bits. So it is 3. Then it is type of flip-flop. Okay. Then the second second step is you have to write the excitation table of the selected flip-flop. Excitation table for the selected flip-flop. And the third step is you have to define the number of states as well as based on that the state diagram has to be followed. Number of states is equal to 2 power n. N represents the number of bits. So it is 2 power 3. Generally, it is 8 here. Okay. So and for the based on that, you have to draw the state diagram. And we are going to use the notation S corresponds to here it is S1 to S8. Okay. Then the fourth step is you have to form the transition table. And based what is the transition table? It is with the present state, next state, and your outputs. So present state, next state, and the output should be the flip-flops. Okay. The fifth step is you have to formulate the schema based on the transition table outputs. And the sixth step is you have to implement the counter. Okay. So these are the steps to be followed. So we can see with the steps for designing an up counter. So first, what is an up counter? Up counter is nothing but a sequential circuit. Up counter is nothing but a sequential circuit which counts from a low value to a high value. That means starts from 0 and it counts up to the maximum value. Okay. So this is the up counter. So what is the first step? It is nothing but the number of flip-flops. So as per the formula, it is equal to number of bits. So it is 3. And what is the type of flip-flop? In the question, it is given where JK flip-flop. So you have to use JK flip-flop. Otherwise, you can go for D or D flip-flop. Okay. And the second step is you have to write the excitation table of this JK flip-flop. Okay. So excitation table consists of the present state Qn, then the next state Qn plus 1, and JK as the output, right? So Qn plus 1, then JK. So as it is, the inputs are Qn plus 1. It is a 2-bit combination. So we got 0, 0, 0, 1, 1, 0, 1, 1. So for JK flip-flop, for 0, 0, then it is 0, don't care. And it is 0, 1, 1, don't care. It is 1, 0, don't care 1, and 1, 1. It is don't care 0. Already it is discussed based on the type flip-flop operation. Okay. Then the third step is the number of states. So number of states is equal to 2 power 3. It is 8 states. So we have the states starting from S1 to S8. So that means 0, 0 to 1, 1, 1. So based on, so the up counter, since it is an up counter, 0, 0 means the next state will be 1, 0, 0, 1. That is 0, 1, 2, like that it will be going on. So we can represent it the state diagram 0, 0, 0, then 0, 0, 1, 0, 1, 0. The next state is then 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, this is the state diagram with all the fields. So it is S1, S2, S3, S4, S5, then S6, S7, S8. All the states we have to find. Step 4 is how to write the transition table. So to write the transition table, we have to consider all the flip-flops, right? So how many flip-flops we have? A, B, C, 3 flip-flops. So what are the present state inputs? Q, A, Q, B, Q, C. These are the present state inputs. Then Q, A star, Q, A star, Q, B star, comma, Q, C star, corresponding next state. Next, outputs. What are the outputs? You have JA, KA, JB, KB, JC, KC are the corresponding outputs. Okay. So based on this, you have to try give the transition table. So the transition table, what are the inputs first? We have to, what are the inputs? Inputs are the present state. So the first flip-flop is QA. So QA, you have to go like this. QA, QB, then QC. Then next state, QC star, QB star, then QC star. These are the inputs. Then what are the outputs? So correspondingly we can write. So it is JC, AC, JB, KB, JA, KB. This is the way we can write all the outputs. So as it is a 3-bit combination, it starts from 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. All the states. What is the next state for 0, 0, 0? It is 0, 0, 1, then 0, 1, 0, then 0, 1, 1. For 0, 1, 1, it is 1, 0, 0, 1, 0, 1, 1, 1, 0, then 1, 1, 1. Well, coming to this 1, 1, 1, what is the next state? Because we have after 1, 1, based on the state diagram, it is 0, 0, 0. So what is the next state here? It is 0, 0, 0. Okay. So we have represented all the flip-flops. Now come to represent your outputs. So how to represent your outputs? You have to choose the present state column QC0, present state QC star. So likewise, you have to select the column based on QC star. QC is the present state, QC star is the next state. Already we have defined the transition table in the execution table 0, 0. 0, 0 corresponds to 0, don't care. 0, 0 corresponds to second also 0, don't care. Next also it has 0, don't care. Next it is 0, 1. 0, 1 corresponds to 1, don't care. 1 corresponds to, what is the value of 1 1? 1 1 corresponds to, it is don't care 0. 1 1, it is don't care 0. 1 1, don't care 0. Then the last is 1 0. 1 0 stands for don't care 1. Okay. Next it is JB, second column, 0 0. So it is 0 don't care. Next it is 0 1. 0 1 corresponds to 1 don't care. Next 1 1. 1 1 corresponds to don't care 0 and 1 0. 1 0 has don't care 1. Then it is 0 0. It is 0 don't care. Then 1 don't care. Then it is don't care 0. The last one is 1 0. For that it is don't care 1. You see these 4 states are repeating, right? Then JAK. So for JAK, you have to choose the present state to be QA and the next state to be QA star. So here it is QA star. Okay. So what is JAKA? JAKA corresponds to 0 1. For 0 1, what is your value? It is 1 don't care. 1 0, it is don't care 1. 0 1, it is 1 don't care. And 1 0, it is don't care 1. Alternately, you are having only 0 1, 1 0, 0 1, 1 2. So it is 1 don't care 1, 1 don't care 1. Okay. So we have written all the transition table. Now we have what are the outputs? JC, KC, JB, KB, JA, K. So for all this, you have to formulate the K map. So for that is your step 5. Step 5 is K map. You have to form for all your outputs JC, KC, JB, JB, JA, K. Okay. So whatever the K map, first we can go for JC. So first you have to write the min terms corresponding to this. What is the min terms corresponding to the value which you are having? You are having 1 for 0 1 1. 0 1 1 corresponds to 3. And you have only 1 for the 0 1 1. So it is summation M of 3. So here the value is 3. Plus we have the don't care terms. What are the don't care terms? You have corresponds to last 4. That means 4, 5, 6, 7. You have the don't care terms to be 4, 5, 6, 7. So based on this, formulate the K map. So you have to write in the order which is in the represented in the present set. So QC, QB, QA, 0 0 0 1 1 1 1 0 0 1. So 3 is 1, 4, 5, 6, 7 are the don't care terms. Remaining all are 0. So only one grouping is possible because only one you have. So this is sender grouping. So what is the value corresponds to JC? It is nothing but QB, QA. Then write for KC. So what corresponds to KC? For summation min terms. What are the min terms corresponding to the value? Only for 7 you are having 1. That is for 1 1 you are having 1 in your transition table. For this value alone you have 1 1 1. So you can write accordingly summation M of 1 7 plus don't care. Don't care terms are which are corresponding to first 4 values. See this first 4 values you have don't care. First 4 values you have don't care means 0, 1, 2, 3. So what is the don't care terms? 0, 1, 2, 3. So the formulator came as it is a three variable K map. You have 8 boxes and represent QC, QB, QA, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. So in 7 means this position 0, 1, 2, 3. Remaining all are zeros. Only the sender value. So you are getting the same value for JC as well as KC. It is 2B, 2A. Okay. Next, similarly, we have to go for JB. JB is equal to. So what are the terms? First, we can check in the transition table. We have the min terms plus the don't care terms. So what are the values you have for 1? So in JB you have corresponds to 001 as well as 101. What is that corresponds to 2 comma 5. So it's what are the min terms corresponding to these 2 comma 5. And for don't care, what the terms you have? For don't care you have 0, 1, 2, 3, then 6, 7. You have 2, 3, 6, 7. That's the don't care term. So you are getting the don't care terms to be 4 terms, 2, 3, 6, 7. So from the K map, so it is QC, QB, QA, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. Okay. So 2, 5. 2 is this one and 5 is this one. Then what are the remaining don't care terms? 2. 2 represents here. Then, sorry, 2 represents the corresponding value by values of JB is 0, 1. So here it is 0, 1. So this is 1, this is don't care, 2, 3, then 6, 7. 6, 7 corresponds to 6 and 7. Remaining two values 0. So sender value is JC is equal to, it corresponds to 2A. So what is the value for JC? It is 2A. Similarly, find the value for KC. KC summation M, the min terms plus the don't care terms. We can check from your two table. So see this KB 0, 1, 2, 3. The position 3 as well as 7, you have the min terms. So position 3 and 7. So you have 3, 7. What are the don't care terms? Don't care terms are you have in KB 0, 1, then 4, 5. 0, 1, 4, 5. 0, 1, 4, 5. Okay, so you can formulate the K map QC, QB, QA, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 3 and 7, 0, 1, 4, 5, don't there, remaining two terms 0. So you can also formulate the same K mapping, so you will be getting the same value for JC as well as KC as QJ. And last term to be your JA. JA is equal to summation M of A, AB. What is the last one? JA, KA. JA has alternatively from 0, 2, 4, 6, 1 and remaining terms you have don't care. So alternatively, we have this one terms corresponds to 0, 2, 4, 6, and don't care is 1, 3, 5, 7. Okay. So what are the, you have all the values to be included in your K map. So definitely your value will be equal to 1. So it is 0, 0, 2, 4, 6. Remaining all are don't care. So we can group all the things. So what is the value of JA? JA is equal to 1. Similarly, for KA. So KA, what is the value we have? Just the opposite of your minterm. So summation M of 1, 3, 5, 7 plus summation don't care of 0, 2, 4, 6. Okay. So it is QC, QD, QA. You have 1. 1 as 1, then 3, 5, 1, 3, 5, 7. And remaining all are don't care. So what is the value again? K is equal to, we'll be getting the same value for J and KA, KB and JB, KC and JC. So now what is the step 6? It is counter implementation, right? So step 6, counter implementation. As you know, how many flip-flops are there? We have 3 flip-flops. So first flip-flop, as it is a synchronous counter, we have to give a common clock first. So first drop all the flip-flops and give common clock to all the flip-flops. So these are the common clock. So J A K J B K B J C K A flip flop B flip flop C flip flop. Okay. Now what is the input to JAKA? It is 1. So we can give a high value of 1 to JAK. And what is the input to JBKB? It is from QA. So this is QA. So you can take the output and give to directly to QA and QB. And what is the expression for JC, KC, QB, QA? So that is nothing but the product of your first flip-flop output and the this is QB, second flip-flop output. So it is this is the input to JC. It is QB and your output should be. So this is the counter implementation diagram, and this is these are the various steps. So far, these are these are 6 steps. Number of flip flops, type of flip flop. Step 1, step 2, excitation table of the flip flop. Step 3, state diagram and the number of states. Step 4 is transition table. Step 5 is the game of implementation, and the 6th one is should be the counter implementation. Hope you have understand this. Thank you.